This is Geometry Section 3.2, learning how to use parallel lines and transversals. In Section 3.1, we learned about the types of angles that were formed when we cut two lines with the transversal. Now we're adding this in the parallel lines, and they are given specific meanings as we are learning this. So grab your theorem sheet out, and we're going to talk about the first four theorems on that theorem sheet. The first one says corresponding angle theorem. It says if two parallel lines are cut by a transversal, and I'm going to write down parallel lines CBT because that is something that you're going to be able to use as an abbreviation, then the corresponding angles are equal. Remember, those corresponding angles are those angles that are in the same position. Think of your desks. All right, so what does it mean? It means those corresponding angles are equal or congruent. We abbreviate that as if parallel lines are cut by a transversal, corresponding angles are congruent. We can set them equal to each other. The alternate interior angles theorem basically tells us the same thing. Alternate interior angles are also congruent. So we've got corresponding angles congruent, alternate interior angles are congruent, alternate exterior angles are congruent. So our first three, in what does it tell me? You should be filling in angles are congruent. The fourth one, consecutive interior angle theorem. If two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. So when we have those two angles on the same side, and I'll say that again, on the same side of our transversal, inside the two parallel lines, then those two angles add up to 180. So let's look at this first example. I see that I have one angle set at 115 and one angle set at x plus 5. Now, I'm going to fill in some of the things that I know, and I can fill in a whole bunch of information. I don't know why that number 4 is there. We'll just call that angle number 4. I know that I have vertical angles, and they are equal. Here's another vertical angle. It is equal. I know that 115 and this angle right here need to add up to 180. If I subtract 115 from 180, I end up with 65. Now there's another vertical angle right there. There's all kinds of different ways that I can figure out these angles. Here's another. If we have x plus 5, we've got 65 over here. Right here is an alternate interior angle. X plus 5, this is going to be 65. This is going to be 65. I can write x plus 6, or x plus 5, sorry, equals 65, or 115 plus x plus 5 equals 180. There's many different ways that I can solve all of those angles. On this second one, I would like you to try it first. We will stop and do it, and then you can fill in the missing angles and check your work with mine. Okay, it says the measure of angle 1 equals 125. Now, I'm going to go ahead and fill in all the other places that are going to be 125. I know that angle 1 and angle 5 are corresponding angles, and this tells me that those angles are congruent. That's one way I can fill that in. I know that angle 1 and 4 are vertical angles, and vertical angles are congruent, so are angle 5 and angle 8. I just filled in all of those angles. Now, how am I going to get some other angles? Well, what does 125, angle 1 and angle 3, we have linear pairs. 180 minus 125 equals 55. So this angle is going to be 55 degrees. Angle 2 is going to be 55 degrees. Now I have an alternate interior angle here and another vertical angle here, ladies and gentlemen. We call that ring around the angles. All you need is one angle with two parallel lines cut by a transversal, and you can fill in all the missing angles. Now sometimes when you have angles cut by a transversal, you might want to extend the lines a little bit. So I'm going to look at this problem example number 1, and I'm going to extend these lines of my parallel lines so that I can see how it's going. And then I'm also going to be doing two different transversals. So here's two parallel lines cut by this transversal. I also have parallel lines that are cut by this transversal. So we're going to stop the video and let you attempt to figure this out. All right, here's your double check. So I'm going to look first at this transversal. And this is pointing to this angle right here. Now these angles are inside my two parallel lines and on the same side, so that I know that 5 times y plus 11 plus 4y minus 10 has to equal 180 degrees. Everybody agree with that? So when I distribute that, I get 5y plus 55 plus 4y minus 10 equals 180. When I combine my like terms, I get 9y plus 45 equals 180. Subtract out 45, and I get 9y equal to 135. When I divide by 9, I get y equal to 15. In this particular case, I'm solving for x and y. I should bring that up a little bit so you can see all this work. Now, I'm going to take a look at this transversal right here. So I've solved my green one. I found out that y equals 15. If I plug that in, I could figure out my angles and make sure they really did add up. It does work. Now I have my transversal here. And I see that, again, I have two interior angles. This is 90 degrees. Well, it has to add up to 180. If this is 90, this has to be 90 also. So I can just simply say 5x equals 90. And that gives me x equal to whatever 5 divided by 90 is. I'll tell you, 5 times 1 is 5, 18. So we have x equal to 18 and y equal to 15, and we just solved that problem. I'm going to do the same thing and extend my lines and then have you stop again. Color in those transversals so you see that you have two different problems here that we're dealing with, and then start filling in what you know based on our theorems. And then stop your video and we will, or stop with the quiz, and then you can double check your work. All right, so the first thing I want to do is kind of fill in what I know for sure. And so if I look at my first green transversal, I see in between my two, I'm doing my red one here, in between these two parallel lines, I see that I have a y plus 10 and a 2x plus 10 that are alternate interior angles. Well, that doesn't help me a whole lot. I see up here that I have also alternate interior angles, 6x and 6x. Now I can see that I can solve 6x plus 30 plus 2x plus 10 equal to 180, which is 8x plus 40 equal to 180. 8x equals 140. X equals 17.5. Now I have to figure out how I am going to substitute in that x for something. Well, we looked at these two angles right here as being alternate interior angles. And now that I know what my x is, I can say y plus 10 equals 2x plus 10. If I know what my x is, 2 times 17.5 plus 10, I can solve for that problem. Equals 35. 2 times 17.5 is 35 plus 10. My 10s cancel out. I get y equal to 35. So I have just solved for x and y in that problem. So see, it gets kind of messy a little bit, but it really works. Again, we're going to do the same thing with our third example. Extend those lines. Color in your transversals. We have two of them. This one and this one. And then we have this parallel line that is cut by this transversal. So again, I'm going to have you stop and I'm going to have you fill in what you know and go on from there. I'm going to fill in all of these vertical angles that I know for sure. That makes it kind of fun. This is 3y. This is x minus 25. I also have 122 and x minus 25, 118. Oh, look at that. Equals x minus 25 plus 34. There's one way to figure that out. There are a multitude of different ways to do that. Right in here, I have supplementary angles. 122 plus x minus 25 equals 180. When I subtract all that out, I get x equal to 83. If I know x is equal to 83, then I can substitute in for my 118 equals x minus 25 plus 3y. I love it. X minus 25 plus 3y. So here is 3y, there is 118. I'm going to say 118, substitute my x in, minus 25 plus 34. 3y, sorry, not 34, I get y equal to 20. That is the most complicated problem you will have to do. So, good luck, and we will do more of these problems in class.